This is Dr. Patrick Hanley at Hanley Innovation. Multi-Surface Aerodynamics is an interactive software package for Windows that allows you to design aircraft such as UAVs, larger airplanes such as sailplanes, and even smaller model aircraft right on your PC in an interactive manner. The programs allows you to design the shape of the wings using airfoils, using the wing taper, wing planform shapes, and then immediately does an analysis. So you're able to tell exactly what your new design is doing, even as you're working on the design. So this gives you an upfront way and quick way to design an aircraft. As you can see, the software is very interactive. You start with a wing shape. You can choose the airfoil shapes. You can choose the dimension of the wing, and you can then join the wings, take a look at them, see what they're doing as you are designing and analyzing. Here we look at the three-dimensional shape of the wing planforms that we just designed. We can see that they're not quite connected, and we can use the tool on multi-surface aerodynamics to snap the two wing sections together. And then, looking at the wings, we can look at the lift distribution across the combined planforms. We could look at moment coefficients and lift coefficients as a function of angle of attack, and we can see the lift to drag ratio, for example, of our new wing design. And we can also look at the lift versus drag. Quickly designing a wing and determining the lift and drag moment characteristics is a desirable feature for a wing analysis package. However, multi-surface aerodynamics takes you several steps further, where the program can be used to do stability analysis. And once you look at your wing, you want to know whether or not this thing is going to be able to fly. So with our analysis, we saw that the wing by itself is not going to be stable, it's not going to be trim. So that suggests adding some more surfaces, and here we are looking at adding horizontal tail section, horizontal stabilizers, and we can then go and do a longitudinal stability analysis for that combination. Unlike the first stability analysis, we see now that the aircraft is now indeed stable and it is flying at a trim condition. So once that is finished, we can then go ahead and do a lateral stability analysis that tells us how our craft is going to react to side slip, and we see that here it's not doing a very good job because all we have are horizontal surfaces. We could remedy this by adding dihedral angles either to the tail, but here in this example we're going to add a vertical stabilizer to our model airplane that we're building here, and we're going to then look at the stability again to see whether we or not we have sized the surfaces correctly, and to see whether we have the desirable performance. So we added the vertical stabilizer. We take a three-dimensional look at it and see how it looks, and we could see that for this skeleton aircraft we definitely see it's beginning to look like a conventional aircraft. For the longitudinal or the lateral stability analysis, we can see now that we have some more desirable conditions for the side slip, and we can also look at the rate of rotation, the rates of yaw that we are getting from our model.